Errors and exceptions in Python. Introduction. Hello everyone. In this tutorial, we will learn about errors and exceptions in Python. We will also learn about how to handle these errors and exceptions. I hope you find this tutorial interesting. Let's enjoy. What is an error in programming? Errors are mistakes or flaws in a program that cause the program's behavior to be unexpected, and even experienced developers can make these mistakes. Programming errors are often known as bugs or faults, and debugging is the act of removing these issues from our programs. There are different categories or types of errors that exist in programming. Whether in a programming script, during program compilation, during program runtime, or the user interaction process. Solving these errors are not difficult. When we understand the logic behind a block of code, we are able to easily mitigate the line or lines of code that give rise to the error. Types of errors in Python. There are two main errors that are experienced by Python programmers. These are syntax errors and logic errors. There are said to be three types of errors that occur in Python. Two have been mentioned, and the third type is runtime errors. In the entire world of programming, there are said to be 8 types or classifications of program errors. I shall explain the Python errors first and thereafter the other types of errors, as they are interesting and I am sure that you would like to read about them. Type of error explanation. Number 1. Syntax error. Important. Syntax errors occur when you have made a mistake in your Python commands. This is often a small issue such as a misspelled keyword or an invalid command. Syntax errors are fixed by going through your code, finding the error, and thereafter correcting it. Number 2. Logic error. Important. This type of error is also known as semantic error. These types of errors do not cause a program to fail and stop running, but it causes the program to produce incorrect output. Number 3. Arithmetic error. Extra. This is a cause of logic error. Arithmetic errors occur when incorrect mathematics has been integrated into your program. Arithmetic errors give rise to runtime errors. Number 4. Runtime error. Extra. As can be inferred from the name, runtime errors are unforeseen errors that occur when your program is executed or while it is running. Runtime errors are quite difficult to locate in a script with many lines of code. Number 5. Resource error. Extra. This occurs internally when your device attempts to assign more resources to the program than it actually has. Alternatively, when your Python script is too much for the CPU or RAM of your PC to handle, your device will crash or a resource error will be thrown to you. Number 6. Compilation error. Extra. This does not occur in Python. This will occur in a programming language such as C++. What basically happens is that the compiler fails to convert our high-level language into machine language. Number 7. Interface error. Extra. Errors that occur when there is a notable difference between the intended use of your software and the current use. Interface errors occur when the program fails to accept or process input according to the way it was programmed to do so. Number 8. Latent error. Extra. These are hidden mistakes that reveal themselves only when a specific type of input is sent into the system, input that the program has not yet learned how to process or handle. What is an exception in programming? These are faults that occur in our programming instance. These errors occur when the code to our program has the correct syntax. An exception occurs when our code encounters an error despite having the correct syntax that it cannot recover from. Python has several built-in exceptions to handle mistakes that may occur in our code. Despite having several built-in exceptions, however, Python allows us to create our own custom exceptions. Exceptions are fault checks that can be inserted by us in a program. The keywords that we use to create our own exceptions in Python are the raise and assert keywords. When an exception occurs in Python, we say that the exception has been raised. It means like the exception error has been brought to our attention. When our code encounters an exception in Python, we say that we catch or have caught the exception. When the exception is passed to our program code for handling, we say that we throw or are throwing the exception. Or when we obtain an exception as output in our Python console, we say that Python or our program has thrown us an exception. Errors arise in a hierarchical form. The exception hierarchy in Python. All exceptions can be visually represented in a hierarchical-like structure. Because Python is object-oriented, all exceptions and errors arise from a main class or type. At the top peak of the hierarchy, we have the base exception. All other exceptions that we have in Python will ultimately arise from the base exception type in Python. For example, one subclass of exceptions that arise from base exception is exception. Exception is the root of user-defined exceptions. That is, all the custom exceptions that are created by us. A portion of the Python exception error hierarchy is shown on the next slide. Notice how the base exception level gives rise to all subclasses and subtypes of exceptions in Python. I would like to mention a logical way of understanding exceptions and errors in Python. Exceptions occur when an error has been found in our code. I would like you to think of it as such. Errors occur in our Python code, and when an error occurs in the code, we get returned an exception, which enlightens us about the type and nature of error. For example, let's say we try dividing by 0. Using mathematics, we know that division by 0 will give us an error. But in Python, Python will not just tell us that your program is failing because of an error on line 7. This would be anonymous and unhelpful to a programmer. We need to know exactly what is causing the error. The exception message that we will get returned to us for the error caused by division by 0 is called the zero division error. And in the hierarchy, this error exception is found under the arithmetic exception group. This helps us to think on the spot that division by 0 is not allowed, therefore our program ran into an error which was a zero division error exception. I do hope that you understand the concept a bit more. You see, when exceptions are encountered in our Python program, we are not restricted to simply watching and having our program crash. Python has built-in tools and features that allow us to handle the encounter with exceptions. The process of correcting our code to handle exceptions in Python is known as exception handling. A few words on exception handling. An exception occurs often because of an error that was found in the code while executing. As a result, the goal of exception handling is to manage an erroneous, incorrect condition that occurs during runtime. Managing the situation could involve maybe terminating the entire script or allowing for the error portion to be skipped to provide a chance for the remaining lines of code in the script to be executed. It's worth thinking about why you'd want to handle an exception. After all, the system won't let a mistake go unchecked. If we try to divide by 0, for example, the system will give you an error. This could indicate that the user typed in an inaccurate value and we don't want users to be confronted with a prompt proposing that they use the system debugger, which is a relatively complex process for non-Python programmers. As a result, we can utilize exceptions to make the user remedy the error and restart the calculation. Handling exceptions in Python. There are quite a few ways in which Python allows us to handle exceptions. They are very interesting. We shall now look at a few of the most important tools or methods in which exceptions are handled. Specifically, we will look at number 1, the raise keyword, number 2, the assert keyword, number 3, the try and except keywords, number 4, a few extra keywords. The raise keyword. So this keyword in Python allows us to raise exceptions, meaning that this keyword gives us, the programmer, the ability to raise exceptions, errors in Python. We have the ability to choose the type of exception that we wish to raise when a particular condition is or is not met. Simply put, we can control if the user will be presented with an error if a certain event occurs. For example, if the user enters an input that we do not want to have in our program, we can send an error to the user and make them re-enter correct information. Let us use an example. Let's assume that we require a user to enter a maximum of 5 characters as input from the keyboard. This means that they need to enter anywhere between and including 0 and 5 characters. If they enter any number of characters above 5, then we need to raise an error exception to them. We would do this as follows. String is equal to input, enter not more than 5 characters. If len string greater than 5, raise exception, please enter valid input, input not accepted. Running the code will give us output as shown below. Enter not more than 5 characters, A, B, C, D, E. Please enter valid input, input not accepted. Notice that the syntax of the raise statement makes use of a standard if statement to conduct the testing process. Therefore, we can also build on this if statement using elif and or else to create a program that handles errors in a much more sophisticated way. Let us work with another example. Suppose we require the user to enter their ID number. In South Africa, ID numbers need to be exactly 13 digits in length, not a digit more nor less. So essentially, we would like to ensure that the length of their input is exactly 13 digits. We can raise an exception for the violation of the rule pertaining to the length of the ID number. We would code the program as follows. String is equal to input. Please enter your ID number, 13 digits. If not len, string is equal to 13. Raise exception, invalid ID number, else print ID number captured. Please enter your ID number, 13 digits. ID number captured. Invalid ID number. We have the ability to raise a specific exception if we would like. Raising exception is sort of a general exception with an error message. If you would like to be more specific, you may raise a more streamlined error or exception, such as a floating point error, type error, or even a value error. I encourage you to play around and experiment with exceptions in Python. Create simple programs and apply the logic of exceptions and try to find out the limitations that exceptions using the raise method bring. The assert keyword. The assert keyword in Python allows us to make assertions in Python. Assertions allow us to make a condition statement in Python that will trigger when that specific condition is met. If the condition is true, then the code block will be executed, and if false, otherwise. Assertions allow us to enforce rules and input checks in our program. A simple example of an assertion in Python using the assert keyword is done as follows. Before we see the code, thinking logically, we know that an age is an integer. An age cannot be a decimal value. An age needs to be greater than 0. It cannot be equal to 0. So using this logic, we implement the necessary logic into our program to cater for and catch all errors that may occur from the user's end. Number is equals to int input, please enter your age. Assert number greater than 0, invalid age entered. Please enter your age 19. Please enter your age 0, assertion error, invalid age entered. Please enter your age 19.5, value error, invalid literal for int with base 10. From my point of view, both the raise keyword and the assert keyword work very well in terms of facilitating the conveying of error messages to the user. However, they have their limitations. One major setback being, when used by themselves, the raise and assert keywords, as we have seen, will cause our program to crash if the condition is met. The point is when the exceptions have been thrown to the user, the program crashes and remaining script execution will terminate. This is not often useful, especially since most applications and user interfaces in today's times require 24/7 execution. For example, in an online form, when you enter the wrong ID number by accident or fall short of digits and try to submit the form, your browser or the form do not crash. Maybe the incorrect text will be highlighted in red or an error message will be thrown, but the program does not crash. It allows us, the user, to correct our mistakes and then resubmit. This leads us to talk about a third and last method of debugging, handling exceptions in Python. I would like to mention that all the techniques of exception handling that we have spoken about thus far and continue to speak about are techniques for debugging code in Python. Exception handling is an approach to debugging. The try and except blocks. The try block and except clause are tailored for exception handling in Python. The logic behind this block of code works very similar to our if and else block of code. The try block of code will hold the indication of code that is to be monitored for the exceptions that are listed in the except clause. The except clause is an optional addition to the try block of code. Within the except clause, we will tell our program the steps to take when a certain exception occurs in our program. For example, would we like to simply let the program execution continue, or would we like to print a warning message to the screen? You may check for as many exceptions as you would like. So essentially what I mean is that there is no limit to the number of except clauses that you may use in your program. A simple example of a try and except block in action. Let us try to capture an integer value from the user, representing the mark obtained by a student for a test. Try mark is equals to int input, please enter mark, accept exception as E, print E. Notice that instead of letting the input line of code stand alone on a line like this, we have placed the line of code in the try block. The try statement will effectively try to execute all lines of code inside it. However, if an error arises, the program does not crash because Python is simply trying to do it. If the lines of code within the try block are not successful, then the interpreter will move to the next lines. In our case, we see an except clause being used. The except clause is the portion of the code that will handle those exceptions. Basically, when code in the try block fails to execute for some reason, the control of our program is passed to the except clause to be handled. The line of code accept exception as E is a very common line of code that is used. It allows us to refer to our exception as the variable E. You can give this variable any name you like as long as you keep it constant in that particular except clause. So By printing the variable e, we are effectively printing the exception itself. And printing the exception is just one way in which you can handle the exception. General syntax of the try and except block of code in Python is as follows. Try, code to monitor for errors. Except, type of exception to monitor for. Code to call if exception is found. So let's look at our program in action, the one about the marks. If you coded it and ran it, you will see that output shows as follows. Please enter mark 50. Please enter mark 13. Invalid literal for int with base 10, 13. Notice that our program has encountered an error because it printed out the exception message, but the program did not terminate upon encountering the error. Under normal circumstances, without the use of the try and except clause, our program would have encountered the same error and terminated with an error traceback message. For example, no try block, no except clause. Mark is equals to int input, please enter mark. And if we enter input of 13 into our program, we would get an error as shown on the next slide. If you look back a few slides to the exception hierarchy in Python, you will notice that we are catching the exception class of exceptions. This means that by using the phrase except exception as E in our code, we are catching all exceptions that may occur because all fall under the class exception. Simply put, we did not enforce any specification in our code. Yes, we are catching exception, but what type of exception is it? It works 100%, but it is a bit too vague. This is why I mentioned that we are allowed to include as many except clauses in our code as we would like to. Also, we have the ability to specify the exception to catch. One more piece of information I would like to mention is that you do not need to include an alias for each exception. You may simply leave the standalone name of the exception in the line of the except clause. I will give you a good example. As an example, our goal is to make a paper grading program. Users will enter the mark obtained. The mark is an integer and ranges from including 0 to 100. We are required to keep a total of the number of marks entered. We must print this number at the end. If the user enters a value of quit as input, the program must terminate. We need to catch any and all errors that we feel could occur. Feel free to make the program as sophisticated as you like. Code and add any features you like and as many features that you like. We just have to ensure that we cater for as many errors as possible. A little interesting side note. In any programming language, one must always code to accommodate errors in the program, even if the probability of running into an error is low. You may use your own discretion to grade papers. If you would like, you may use the below guide. A. 80 to 100, B. 70 to 79, C. 60 to 69, D. 50 to 59, E. 40 to 49, F. 0 to 39. I have coded my script and I have added a few additional features to it. I may have not mentioned this before, but feel free to leave links to your scripts of code in the comment section below. Here is what I have. Please correct me and pardon me if I have made an error in my script. Take note of how our try block of code can execute our regular Python syntax: if elif else ladder, take in input, perform arithmetic, and much more, loops, functions, and any other Python events in an attempt to check for errors. And below all that we have our except clause, which will handle the exceptions if any arise from the try block. I've ran our script a few times and output to the program will show as follows. Notice that even though our program is returning errors to us, script compilation and interpretation does not terminate. I would like to show you another example. An example in which we attempt to catch several exceptions by their name. We have the choice to assign our exception a different name and then refer to it by the chosen name thereafter. Also, we do not have to give all variables the same name, but we could if we want to. Looking at the code for the example on the previous slide, we see that we have defined a function that is called division function. Our division function takes in two arguments for two parameters. Parameter names are x and y respectively. This function requires us to pass in two numbers and it will return to us the answer to the division of x by y. We have catered for two possible scenarios of errors, the first being division by 0 and the second being missing y argument or no argument. Let us run our code now and see the output. In the try block, with the value of 5 and 0 passed in for x and y respectively, we get the following output. Division by 0 is not allowed. In the try block with the value of only 5 passed in for the x parameter, leaving the y blank, we get the following output. How to catch any exception. It is possible to catch any exception using an except clause in your code. An example being, the first portion of code that we need to notice is the last except clause. There is no exception specified or tied to this except clause. Therefore, if any error occurs in the code, even if it was one that we did not take into consideration, the content of this except clause will be executed. Notice that on the previous slide, we do not pass in any argument for the y value. We pretend we do not realize we missed a y value and we run the code. Output will be seen as shown on the next slide. I don't know what error it was, but something went wrong. The except clause with no specification of exception tied to it must be the last except clause from all your except clauses. As we have seen, it allows us to get notified that an error did occur in our code, although we do not know what type of error it actually was, nor where it occurred. Therefore, use this feature with caution. The else clause. Our try and except block of code can also have an optional else clause integrated to it. If you would like to use the else clause, you will need to place this clause after all except clauses in the code. The else clause is only executed if no exceptions were raised. If any exceptions were raised by the except clauses, then the else clause block of code will not be executed. A good example of the else clause in action is as follows. Looking at our code, we expect the else clause to run only if there are no exceptions raised in the try block. And looking at the try block of code, we see that we have passed in 6 and 2. So we can be assured that the division function will return to us a value of 3. Therefore, we expect no error to arise because we only cater for 0 division error, and in this instance we are not dividing by 0. Therefore, no error to be raised, and we would expect to see the else clause execute. 3.0 The function yields results. Experiment with the else clause and try passing in a calculation in which division by 0 occurs. The finally clause. The syntax of the try except block of code also has an optional finally clause. The finally clause must be the last clause in the syntax. It must appear after any and all except clauses and the else clause. The finally clause will be used to run code whether an exception occurred or not. As an example, we see the below code. Looking above, we see the else clause appearing after our last except clause, and the finally clause appearing after the else clause. As we've said, the finally clause will execute the code within whether an exception was raised or not. So essentially we see that we passed in the values 6 and 0 to the division function. Therefore, we expect to get a 0 division error. Therefore, the error will be printed. The else clause will not be executed because it will only execute if no exception was raised. And finally, we expect the code within the finally block of code to be executed, since it will always execute irrespective of the presence or absence of exceptions. So we will see output as follows. Division by 0. Epic, we just reached the end of exception handling in Python. Conclusion, and here we are at the end. Well done, guys. We have effectively and efficiently learnt all that there is to know about exception handling in Python. There are a few more use cases of exceptions in Python. I will make a future video that covers these. However, they are not anything too difficult to handle. Thank you for watching and reading to the end of this tutorial. I do hope that you have valuable takeaways from this tutorial. Thank you for your time. PS. Don't forget to experiment with the keywords learnt in this tutorial. Also, thank you guys. Do make sure to like, share and subscribe to my channel. It will greatly support me. Thank you.